Hello everyone and welcome back! In the last lesson we have introduced JSON Web Tokens on a high level. Let's now drill down on the JSON Web Token format. Let's understand exactly what is the JSON Web Token header, payload and the signature. It's important to understand that JSON Web Tokens are not encrypted, so each of these free strings that we have here is in base 64. So this payload here is not encrypted and it should not contain sensitive information that the attacker could use, such as, for example, passwords. So let's see what this looks like. Let's copy paste this string. We are going to see that this is public information, although it looks like it could have been encrypted somehow. Let's take the string and head over to base64decode.org. We are going to paste this string here. We are going to hit decode. And this is going to transform this string from the base64 encoding format into another encoding format. In this case, the target encoding is UTF-8 as it's specified here in the drop-down box. So if we now hit decode, and as you can see, if you scroll down, we have here the exact same JSON object that we have here. So as you can see, the first part of the JSON Web Token is simply a base64 encoded string. The alg property stands for algorithm, and this provides all the information necessary to be able to validate the signature. More on the signature in a moment. Right now, let's have a look at the second part of the JSON Web Token, which is the payload that we can see here in purple. Let's have a look at this second base64 string. So if we head over again to the same website and we paste it here, we are going to see that this is also simply a JSON object encoded in base64, which corresponds to the payload. So here we have the payload. As you can see, the payload is not encrypted. So it's very important to never put any sensitive information in the payload of a web token. What we're putting here is just a technical identifier to a subject that would allow us to know this request corresponds to this user. We don't need a session ID for that. What we need is instead a self-validating token. What would prevent in a JSON Web Token for an attacker to forge a request? Simply create an object with a given payload. Let's say that somehow the attacker would get access to the subject. It would put the subject here and send this together with an HTTP request attempting to impersonate a user. What would prevent this attack scenario given that the payload is not encrypted and everything could be edited by an attacker? What prevents that from happening is the third part of the JSON Web Token, which is the signature. Again, let's have a look at it with the decoder. We are going to paste this here to the base64 decoder. Notice that we have cleared here the result. Let's hit decode. So this time around, we did not get a JSON payload. We got a binary file that got downloaded. So the third part of a JSON Web Token is not a JSON payload. This is a cryptographic signature. This is the part that proves that the payload is correct and was sent by a given third party. Let's see how the signature works. You will notice here that there is here a key called secret. We are going to talk about how this keyword is being used to produce a signature. Right now, let's just understand on a high level how secret is being used. So this password is going to be used by the sending party that created the JSON Web Token with a given claim, meaning this request belongs to this user. The sending party is going to use the secret keyword, this string here, is going to use it to produce the third part of the JSON Web Token. The receiving party will also have this string somewhere in their system. The receiving party will use the secret password to validate that the JSON Web Token is indeed valid and sent by someone that had access to the secret password. Using a shared password between the sender and the receiver is just one of two ways that we have available for producing a signature. we have here another way that does not require sharing a password between the two parties. We're going to go into that in a moment. Right now, before going any further, let's quickly summarize what a JSON Web Token is. A JSON Web Token is simply a mechanism for a sending party to send a claim to a receiving party. The claim is a JSON payload. It's typically used for authentication and it's typically attached to an HTTP request. The token itself, it's just a string with 3 parts separated by dots. Nothing is encrypted, so we cannot put sensitive information that an attacker could use in the token. The first part of the JSON Web Token specifies which type of signature we are using. The second part contains the payload. Typically, it identifies the user that the HTTP request is associated to. The last part is the signature. So the presence of a signature makes the JSON Web Token a self-validatable token. So when we receive a JSON Web Token, if we want to make sure that the token is a valid token issued by the correct party that we are expecting, we only need to look at the token itself to confirm that. We don't need to call a third party to see is this token valid or not. We don't need to store it in memory at the level of the server and then compare it once we receive a token over the network. We can create the web token and send it over the network and forget it, delete it from memory. The receiving party, to validate the token, will only need to inspect the signature. There are 2 available mechanisms for signing a JSON Web Token, HS256 and RS256. So we are going to understand both. Let's go over them.